Assalamualaikum warahmatullahi wabarakatuh. I'm Jenny Agista Putri with NPM 2341171 from Class Management and Nutrition. So here in this last video, I will tell you what is decision theory. So the first thing is decision theory. Decision theory is a branch of applied mathematics and statistics that provides a systematic framework for making decisions in situations where outcomes are uncertain. It involves evaluating different possible actions or strategies based on their potential outcomes and associated probabilities. The goal of decision theory is to help decision makers choose the best course of action by quantifying the risks and rewards associated with each option. The process often involves constructing decision models that incorporate various alternatives, states of nature, and payoffs or losses from each combination of alternative and state of nature. At the core of decision theory is the concept of expected value, which represents the average outcome of a decision, weighted by the probabilities of different states of nature. Decision makers may use different decision rules to guide their choices, such as maximize the maximum payoff or minimax regret rule, which minimize the potential regret from not choosing the best decision after the fact. These rules provide ways to balance risk and reward, depending on the decision maker's attitude toward uncertainty. In more complex cases, Bayesian decision theory allows decision makers to update their beliefs about the likelihood of different outcomes based on new evidence. And the second thing is the factors. In decision theory, several factors influence the decision-making process, helping individuals and organizations assess the risks, rewards, and uncertainties associated with different options. One of the key factors is the alternatives, or the different courses of action available to the decision maker. These alternatives could range from strategic choices, investments, or operational decisions. Depending on the situation, the number and nature of alternatives can significantly affect the decision-making process, as more options may offer greater flexibility but also introduce more complexity in evaluating potential outcomes. Another important factor is the state of nature, which represents the various future scenarios that are uncertain but can influence the results of the decision. For instance, in a business context, the probabilities, the states of nature could include outcomes like the high demand, moderate demand, or low demand. The probabilities of these states occurring may not always be clear, but they play a critical role in evaluating the potential outcome of each alternative. The decision maker often needs to estimate. And next is independence. The independence of events is another key factor in probability. If two events are independent, the occurrence of one event does not affect the probability of the other. For example, flipping a coin and rolling a die are independent events. Getting head on the coin toss does not change the chance of rolling a 3 on the die. When events are independent, the probability of both events occurring together is simply the product of their individual probabilities. In contrast, dependent events are those where the outcome of one event affects the probability of the other. For example, if you draw two cards from a deck without replacement, the probability of drawing a specific cards on the second draw depends on the card you drew first. And then there's the law of large numbers. The law of large numbers is a principle in probability that states that as an experiment is repeated many times, the observed relative frequencies of outcomes will get closer and closer to the true probability. For example, if you flip a fair coin a small number of times, their proportion of heads and tails may vary significantly. However, if you flip the coin thousands or millions of times, the proportion of heads should approach 50% as predicted by probability. This factor highlights the role of repetition and sample size in determining probabilities. And next, we move to the example. The question is, a courier works for a delivery company that handles two types of deliveries, delivery A and delivery B. The company's data shows the following: 60% of all deliveries are delivery A and 40% are delivery B. For delivery A, 90% of packages arrive on time, and delivery B, 80% of package arrive on time. The question is, if a package arrives on time, what is the probability that it was delivery A? And the solution is, this problem can be solved using Bayes' theorem. We want to find the probability that the package is delivery a given. The step 1 is calculate the PT. The total probability that a package arrives on time can be calculated by assuming the probabilities of the package being on time for each type of delivery. As you can see, that's the formula, and we have to substituting the known values based on the questions. Now calculate the PT. And step 2 is calculate P times A divided T. Now we can calculate the conditional probability. And the interpretation is, if a package arrives on time, the probability that it was delivery A is approximately 62.79%. Next is probability distribution. The probability distribution describes how probabilities are spread across different outcomes for a random variable. For discrete random variables, the distribution is represented by a probability mass function, as known as PMF, which assigns probabilities to each individual outcome. For continuous random variables, the distribution is represented by a probability density function, as known as PDF, which gives the likelihood of outcomes within a specific range. Understanding the probability distributions of a random variable is essential for calculating expected values, variance, and for making predictions about the behavior of random systems. And the second one is the factors of probability. The first factors is sample space. The sample space is the set of all possible outcomes of an experiment. The size and nature of the sample space play a crucial role in determining probabilities. For example, when flipping a coin, the sample space is head, tails, and head, tails, and there are only two possible outcomes, which makes the probability of each outcome is half. In contrast, if you're rolling a six-sided die, the sample space is, and each outcome has a probability of 1.1 out of 6. The structure and number of outcomes is the sample space directly affect calculating a probability for any event. And next is conditional probability. Conditional probability refers to the probability of an event occurring given that another event has already occurred. This factor is crucial when events are not independent. For example, if you know that it is raining, the probability that someone is carrying an umbrella increases. This is a conditional probability because the likelihood of carrying an umbrella depends on the condition of rain having occurred. The concept of conditional probability is used to revise our expectation when new information becomes available.